Normandy, July 1944. A mile outside of St. Lo, the air is thick with humidity and the smell of rotting vegetation. When the lead scout crosses an invisible marker, the German machine gun opens fire. The sound is a violent, fabric-tearing roar. He had the authority to assign the guns immediately. The computers enlisted men trained in rapid battlefield trigonometry took over the process. Using graphical firing scales, plotting pins, and protractors, they mathematically translated the muddy infantryman's map grid into exact mechanical adjustments for the howitzers. They calculated deflection for left-to-right aiming and elevation for distance, factoring in the powder charge, the weight of the projectile, and even the current wind speed. These precise numbers were transmitted instantly via field telephone to the gun lines. Crews hastily cranked their 105mm barrels into the sky, sliding heavy brass casings into the breaches. From the moment the infantryman in the sunken lane keyed his radio handset, it took only 2 to 3 minutes for the first spotting round to leave a barrel. If the first shell landed wide, the lieutenant in the ditch simply keyed his radio again, whispering a quick correction: drop 50, right 50. The FDC adjusted the math in seconds. Then came the command that doomed the German defenders: fire for effect. The FDC possessed the communication network to link not just one battery, but multiple batteries across the sector, aiming their fire so that shells originating from entirely different locations impacted the German hedgerow at the exact same moment. This was the terrifying machinery the German scout had unknowingly engaged. He believed he was ambushing 12 isolated riflemen. 1,200 rounds per minute chew through the humid summer air. Dust, splintered wood, and pulverized rock explode from the road surface. In reality, he had triggered an electrical switch connected to an invisible network capable of dropping a concentrated storm of high explosives anywhere on the battlefield, with devastating flexibility. The bombardment tore through the hedgerow, shredding the thick hawthorn canopy, collapsing the earthen walls, and burying the primary German machine gun position. But high explosives carry a fundamental limitation. They can shatter a defense, silence a gun, and break morale. But artillery shells cannot capture a field. As the dust settled and the ringing in their ears faded, the surviving German infantry began to recover, remanning their secondary positions in the brush. The barrage had temporarily blinded the defenders, but to permanently clear the maze, the pinned-down Americans still had to stand up and advance. To understand how they achieved this in a landscape built to isolate them, we must look at how the radio changed the way the infantry themselves moved. The artillery barrage stopped. The dirt was still settling over the German positions. For the 12 Americans in the sunken lane, the most dangerous moment had arrived. Artillery could momentarily deafen and bury a defender, but high explosives could not hold ground. To completely neutralize the ambush, the infantry had to stand up, move forward, and clear the remaining trenches. In the claustrophobic bocage, this meant stepping back into the line of fire. Traditional fire and maneuver required one team to lay down a base of suppressive fire while another team flanked the enemy. But that doctrine relied on visual contact. The Americans hit the dirt instantly, pressing themselves violently into the shallow, muddy ditches. They are completely pinned. The suppressing team needed to see their maneuvering comrades to know when to shift their fire, ensuring they did not shoot their own men. In the hedgerows, a flanking squad vanished behind a wall of roots the moment they moved out. Without sight, uncoordinated movement meant either friendly fire or walking blindly into a second trap. This was where the smaller, seemingly less impressive radio changed. The tactical geometry of the fight. The SCR 536 handy-talkie allowed for something completely alien to the defending German infantry: invisible lateral communication. Instead of charging blindly up the lane, the American platoon divided its labor. One squad remained in place, bracing their heavy Browning automatic rifles against the earthen bank. They unleashed a steady, deafening bass of fire directly into the smoke-filled German line. Meanwhile, a second squad broke off, slipping through a narrow gap in the adjacent hedgerow. The flanking squad was completely out of sight, navigating a parallel pasture, but they were not out of contact. The squad leader carried a handy-talkie pressed to his ear. Through the static, he maintained a running dialogue with the suppressing squad. He reported their progress, yard by yard. When the flanking unit reached the edge of the German position, preparing to breach the final wall of foliage, the squad leader keyed his radio and gave a simple command to shift fire. Instantly, the deafening roar of the American base of fire ceased its forward trajectory. According to every established rule of infantry combat, this patrol is already dead. They cannot see past the earthen walls, and pivoted outward, creating a safe corridor. The flanking squad surged through the brush, catching the surviving German defenders entirely exposed from the side. To the German survivors, this coordination was baffling. They were used to fighting enemies who attacked in waves or advanced along predictable, visible lines. Instead, they found themselves fighting a ghost network. Every time a German gun fired, it was immediately suppressed from the front, while an unseen element closed in perfectly on the flank. The American infantry did not fight as a disconnected mob. They moved as a fluid, overlapping web. They used the radios to stitch the fragmented landscape back together. If one squad hit a wall, they became the anchor, and another squad simply flowed around the obstacle, guided entirely by voice. This method turned the terrible terrain from a death trap into a manageable, albeit deeply bloody, tactical problem. By maintaining constant communication across the blind spots, the Americans stripped the defender of their primary advantage. The Germans could see the devastating results firsthand. They were veteran soldiers who fully understood the concepts of suppressive fire and flanking maneuvers. They recognized exactly what the Americans were doing to them. But observing a tactic is not the same as possessing the capability to execute it. If the secret to breaking the bocage was simply lateral communication and overlapping teams, the question remains, why did the highly experienced German army not simply adapt and copy the method? They have no line of sight to their company commander. They are trapped in a predetermined kill zone. The answer was not a lack of tactical imagination. It was a problem of profound, hidden mathematics. The German soldiers fighting in the hedgerows were not blind. They captured American equipment off the dead. They recognized the short, flexible antennas protruding from the brush. They understood exactly how the SCR-300 and the handy-talkie worked. The tactical genius of overlapping fire directed by voice was painfully obvious to any veteran officer who survived an encounter with it. So, the question naturally arises, if the system was so undeniably effective at bypassing the terrain, why did the highly experienced German military not simply replicate it? The answer was not a lack of tactical imagination. It was a profound limitation of chemistry and logistics. The invisible web that saved the American patrol was not just a brilliant concept. It was a hungry, fragile machine that required constant feeding. Consider the radios themselves. They were rugged pieces of engineering, but they were fundamentally reliant on dry cell batteries. The handy-talkie required the specific BA-38 battery, which, under constant transmission and receiving in combat conditions, might last only a single day, sometimes just a few hours. The larger SCR-300 backpack radio relied on a heavy, rectangular battery block, often the BA-70, that provided roughly 20 hours of operational life. In this environment, a cut-off squad must fight alone with only the weapons they carry. They must either bleed out in the dirt, wait for dark, or surrender. When the chemical energy inside those casings was spent, the communication web collapsed entirely, and the radios instantly reverted to dead weight. Replicating the American system required far more than merely copying a circuit board. It required the industrial capacity to manufacture tens of millions of perishable batteries, ship them across the Atlantic Ocean, offload them on contested beaches, and physically drive them over rutted dirt roads, directly to a rifleman shivering in a wet Norman ditch. The United States possessed this unbroken, continuous river of supply. Germany, in the summer of 1944, did not. Their industry was increasingly strangled by strategic bombing. They lacked the abundant raw materials like zinc and high-grade carbon needed to produce disposable, short-lived batteries on such a massive scale for frontline infantrymen. Furthermore, their supply lines in France were constantly shattered by Allied aircraft. A German infantry unit could capture a perfectly functioning American handy-talkie, but within hours, it would be nothing more than a useless brick of aluminum. The same brutal mathematics applied to the artillery. The American Fire Direction Center could drop a massive, synchronized barrage onto a single concealed machine gun nest because the United States had the mechanized transport to deliver thousands of high-explosive 105mm shells to the gun lines every single day. The German artillery, increasingly reliant on horse-drawn carts, but the expected panic never materializes. No American officer stands up, waving his arms to direct return fire, and suffering from severe ammunition rationing, had to carefully hoard its heavy shells to break up major tank assaults or support large counterattacks. They simply could not afford to spend precious artillery on local, squad-level skirmishes. The German scout in the sunken lane was not just fighting 12 men, he was fighting the factories in Detroit, the chemical plants in New Jersey, and the massive cargo ships crossing the Atlantic. He was fighting an industrial system that could afford to spend heavy ordnance and disposable technology to solve local tactical problems. This network of portable radios and abundant artillery gave the Americans a distinct, undeniable advantage in an isolated firefight. But a single skirmish in one sunken lane does not break an entire front. The true test of any military system is friction and scale. The American machinery had proven it could quickly reverse an ambush. The deeper question was, what would happen when this complex, battery-hungry, highly connected system was forced to grind its way through thousands of identical, heavily defended hedgerows, day after grueling day. Across the Cotentin Peninsula and the approaches to Saint-Lô, the brief, violent firefight that erupted in the sunken lane was repeating itself 1,000 times a day. By late July, the Norman countryside was not a theater of sweeping, cinematic, armored maneuvers. It was a landscape of continuous, localized destruction. No runner scrambles desperately backward down the lane to fetch reinforcements. The trapped men barely move, keeping their faces in the mud. Platoon by platoon, the American army was feeding the ancient bocage into a grinding machine. The accumulation of these small, radio-directed engagements fundamentally changed the operational tempo of the war. Instead of launching massive, rigid offensives that the German army was historically trained to absorb and counterattack, the United States forces engaged in a relentless, crawling attrition. An American infantry company would move forward 50 yards, hit a camouflaged German defensive line, fall back to cover, and let the invisible network go to work. The infantry acted as bait and spotters. The fire direction centers did the heavy lifting. Once the artillery lifted, the overlapping infantry teams pushed forward, using their handheld radios to coordinate the clearing of the shattered trenches. Then they crossed the next field, hit the next hedge, and keyed the microphone again. For the German command, This methodical process was a strategic nightmare. They had garrisoned the hedgerows, expecting to bleed the attacking Americans white. But the invisible system was reversing the arithmetic of the battlefield. Every time a German unit revealed its position by firing, it was immediately identified, located on a grid, and subjected to a crushing weight of artillery. The defenders were losing irreplaceable veterans, anti-tank guns, and heavy machine guns, not in decisive, pitched battles, but in endless, grinding skirmishes. The German defensive line in Normandy was never cleanly broken in a single afternoon. It was systematically pulverized over 6 weeks. Yet, without any visible signals, something impossible happens. Within exactly 3 minutes, the sharp, hollow thunk of a mortar echoes in the distance. But this mechanical efficiency did not mean the war had become sterile, distant, or bloodless for the Americans. The system was a marvel of communication and industrial firepower, but it possessed a terrifying appetite for frontline infantrymen. The radio network could summon artillery to shred the hawthorn canopy and suppress the heavy weapons, but high explosives could not reliably collapse deep, reinforced dugouts, burrowed under centuries of thick oak roots. Artillery shells could not secure a crossroads or occupy a village. Ultimately, the men still had to step out, from behind the dirt walls, and cross the open pastures. They still had to crawl through the mud, throw fragmentation grenades over the embankments, and clear the muddy ditches at point-blank range. The invisible web made tactical success possible, but it did not make the advance cheap. American infantry divisions fighting in the bocage suffered staggering casualty rates, with some rifle companies experiencing near-total turnover in a matter of weeks. The system ensured the invasion did not stall, but the machinery of fire support and lateral communication required human operators to step into the kill zone, draw fire, and hold their ground while the mathematics of the artillery caught up. The immense scale of the destruction proved that the battery-powered network could break the German army. The thousands of ruined fields and shattered concrete bunkers were the physical evidence of its success. A high-explosive shell detonates precisely 40 meters behind the German position, sealing off their only retreat trench. But the vast, continent-spanning mechanism of factories, supply ships, plotting tables, and howitzers was completely dependent on a fragile connection at the very front. To understand the true weight of this system and the reality of what the German scout was fighting, we must return to the men trapped in the mud and look at the specific, fatal burden carried by the soldier holding the transmitter. In the sunken lane near Saint-Lô, the brief, deafening violence of the ambush has ended. The German scout carefully peers through the shattered remnants of the hawthorn canopy. His primary machine gun position is completely buried under a fresh crater of pulverized earth and splintered roots. The 12 Americans he had expected to easily annihilate are already moving out of the muddy ditch. They advance through the drifting smoke in overlapping, coordinated strides, their weapons raised, methodically clearing the remaining corners of the pasture. The veteran defender finally grasps the terrifying reality of the battlefield. He had not engaged an isolated squad of riflemen. He had pulled the trigger on a single nerve ending connected to an industrial giant. The puzzle of the American advance in the bocage was never really about how infantry could physically cut their way through a claustrophobic green maze. A veteran German scout presses his shoulder against the steep, centuries-old earthen bank of a sunken lane. Seconds later, a second shell impacts the adjacent field. Then, the ground begins to violently shake. It was about how an entire military force had successfully bypassed human vision. By pushing the tactical radio down to the lowest ranks, the United States had woven an invisible electronic nervous system over a landscape that was specifically designed to fracture armies. But this vast, continent-spanning machinery of massed artillery and infinite supply was entirely tethered to a fragile point of failure. The entire system bottlenecked at the shoulders of the individual infantryman assigned to carry the transmitter. To be a radio man in the Normandy hedgerows was to carry a death warrant. The German defenders quickly learned that the most lethal weapon the Americans possessed was not the armored tank or the submachine gun. It was the thin, flexible steel whip antenna swaying just above the tall grass. German snipers and veteran gun crews were explicitly ordered to scan the foliage for that wire. The radio man was burdened with 40 pounds of metal and chemical batteries, making him slow, clumsy, and exhausted in a firefight. Every time he stood up to move, he marked himself as the single most important target on the battlefield. When he keyed his microphone, he unleashed an avalanche of steel upon the enemy, but he also drew their desperate, concentrated fury. 105mm artillery shells screamed down from the sky, landing with terrifying mathematical precision directly onto the German defensive line. The systematic destruction of the German defensive line was not a sterile miracle of radio technology. The invisible web was built and sustained by human labor. It was made real by factory workers assembling copper components in New Jersey, transport drivers navigating muddy European lanes under artillery fire, and quartermasters hoarding precious batteries on the chaotic beaches. It functioned because anonymous enlisted men in the fire direction centers spent sleepless nights calculating geometry on acetate maps, and artillery crews permanently deafened themselves, ramming brass casings into hot breaches. The invisible machinery ultimately broke the deadlock, but its actual weight was carried in the dirt. The German scout begins to crawl backward through his escape trench, abandoning the ruined lane. Behind him, the American patrol successfully secures the perimeter. In the center of the squad, an exhausted young private adjusts the heavy canvas straps, digging into his bruised shoulders. He kneels in the damp Norman mud, pulls the heavy black Bakelite handset to his face, and presses the transmit button. Above his helmet, a thin wand of steel quivers against the gray sky, keeping the line open. Simultaneously, heavy machine gun fire begins tearing through the hawthorn bushes from a completely different angle, cutting the foliage to shreds and entirely suppressing the German crew. The German scout is forced into the bottom of his trench, bewildered and deafened. The American reaction was far too fast, too heavy, and too accurate. The men in the dirt were entirely blind, cut off by massive walls of earth, utterly unable to signal their own lines with flags or flares. They were just a dozen men, armed with rifles and submachine guns. Yet they had somehow reached out across miles of invisible space and instantly pulled an avalanche of steel down onto a camouflaged enemy they could not even see. To the veteran defender, this made absolutely no sense. Wars were fought with sightlines, runners, and physical coordination. This felt like fighting a single, massive organism. To understand why this ambush failed, and why the German troops slowly realized they were fighting a machine they could not comprehend, we first need to look at what the terrain was supposed to guarantee. We must understand why the defenders believed the ancient hedgerows had already won the battle for them. Woven above his head is a dense canopy of hawthorn, briar, and oak roots, creating a claustrophobic tunnel of green. For centuries, Norman farmers had divided their land into a patchwork of small, irregular fields. The borders of these pastures were not simple wooden fences. They were massive earthen embankments, sometimes 3 to 4 meters thick at the base, reinforced by the centuries-old, intertwined roots of oak, ash, and dense briar. To the German High Command, in the summer of 1944, this prehistoric terrain, the bocage, was a perfect, ready-made fortress. It was a landscape seemingly designed by nature to strip away everything that made the American military terrifying. The German tactical doctrine in Normandy was built on a very specific, logical premise: compartmentalization. The defending army knew they could not match the raw industrial output or the crushing air superiority of the Allied forces. But in the hedgerows, those advantages seemed entirely irrelevant. Allied bomber pilots could not see through the dense canopy to identify camouflaged targets. American Sherman tanks could not simply drive through the thick walls. When they tried to climb the steep dirt banks, their thin belly armor was exposed directly to German anti-tank weapons. The environment forced the Americans to fight on foot, creeping blindly from field to field. More importantly, the terrain destroyed the basic mechanics of traditional command and control. In standard infantry warfare of the era, coordination relied heavily on human senses. Platoon leaders used hand signals to direct their squads. 50 meters down this dirt track, his machine gun crew waits in a concealed pit. Their MG-42 sighted perfectly down a 75-meter stretch of exposed ground. Company commanders relied on field telephones connected by fragile lengths of wire, or they sent human runners sprinting across the battlefield to deliver handwritten orders. Artillery observers required a high vantage point with a clear line of sight to walk their high-explosive shells onto a target. The bocage severed all of these connections. A typical Norman pasture was perhaps 100 meters across, walled in by towering foliage. Once an American patrol stepped into one of these enclosures, they vanished from the sight of their own commanders. If a firefight erupted, a runner trying to carry a distress message back to the command post would have to scramble blindly over exposed, heavily targeted earthen walls. Field telephone wires, if they could even be laid, were instantly shredded by mortar shrapnel or crushed by retreating vehicles. To the German defenders, this meant the battlefield had been successfully atomized. They believed they had forced the invasion into a primitive, fragmented brawl. Their strategy was simple: place a machine gun at the corner of a field, pre-sight mortars on the center of the clearing, and wait. When the Americans entered, they would be instantly pinned down. Blinded and cut off from their officers, the isolated squad would panic, freeze, and be destroyed in detail. The terrain would turn a massive, modern army into thousands of disconnected, terrified men fighting completely alone. The scout has fought in the vast open steppes of the East, where visibility was measured in miles. For the first few weeks of the invasion, this brutal calculus seemed entirely correct. The hedges swallowed entire American battalions. The advance slowed to a bloody, crawling pace. But the German scouts watching the sunken lane near Saint-Lô had just witnessed a profound contradiction to this rule. The American patrol in the dirt had undeniably been trapped. Their physical line of sight ended at the dirt walls, 3 feet from their faces. No runner had escaped to carry coordinates. No wire trailed behind them to a telephone exchange. Yet, the overwhelming artillery response had been calculated, authorized, and delivered in less than 3 minutes. The German assumption was perfectly logical, but it contained a fatal blind spot. They believed that because the terrain blocked human sight, it also blocked human communication. To understand how the trapped patrol had shattered that assumption, we must look at what the men in the dirt were actually carrying. The Americans had not defeated the bocage by destroying the terrain. They had bypassed it entirely, using an invisible lifeline that the defenders simply did not possess. The answer to the German puzzle was carried on the back of a single, sweating infantryman. While the German army relied heavily on miles of fragile copper wire and human runners to link its frontline trenches. But here, in the Norman bocage, sightlines are reduced to mere feet. He knows the lethal geometry of this terrain. The American military had initiated a quiet revolution. They had decided that wireless communication was no longer a luxury. reserved for generals, command posts, or armored vehicles. They pushed the radio all the way down into the mud, directly into the hands of the frontline squads. The defining piece of this invisible network was the SCR-300. It was a bulky, olive-drab metal box strapped to a specialized canvas pack frame, weighing nearly 40 pounds when fully loaded with its heavy dry cell batteries. To the German observer, the radio man looked like just another burdened infantryman, distinguishable only by the thin, flexible steel whip antenna swaying above the brush. But that heavy box changed the fundamental geometry of the battlefield. The SCR-300 was an FM, or frequency modulation, transmitter and receiver. Unlike older AM radios that crackled with atmospheric static and the electrical interference of battle, FM delivered a clear, recognizable human voice. A platoon leader crouching in a ditch did not need to tap out Morse code or scream over static. He could speak in a low, urgent tone. It had an effective range of about 3 miles. In the open desert, that was a short distance. In the claustrophobic hedgerows, 3 miles was more than enough to reach over the impenetrable earthen walls. He has done this before. Let the enemy advance, seal the corridor, and cut them down, and connect the isolated patrol to the rest of the battalion. Further down the chain, the integration was even tighter. Platoon commanders and sometimes squad leaders carried the SCR-536, universally known as the handy-talkie. It was a 5-pound, rectangular aluminum brick. You pulled out the telescoping antenna to turn it on and pushed a single heavy button to speak. It only reached a fraction of a mile, but it allowed men on opposite sides of a thick hedge to coordinate their movements without shouting and giving away their positions. These 2 pieces of equipment meant the men pinned down in the sunken lane near Saint-Lô were never truly cut off. When the German machine gun opened fire, the American squad did not freeze because they did not have to solve the tactical problem alone. They instantly became the sensory nodes of a much larger, unseen organism. While the riflemen pressed their faces into the dirt to avoid the stream of incoming bullets, the platoon leader grabbed the black Bakelite handset of the SCR-300. He did not need to run back to a command post. He simply keyed the microphone. He transmitted their exact position. 12 American infantrymen step cautiously into the sunken lane. They walk in a staggered file, their olive-drab uniforms blending poorly with the shadows, using a standardized map grid. He described the location of the enemy fire. He requested immediate suppression. His voice carried effortlessly over the hawthorn canopy, completely invisible to the German gunners, traveling at the speed of light to a receiver sitting safely behind the lines. The ancient terrain had successfully blocked human sight, but the radio waves passed directly over the roots and dirt. The German scout saw 12 isolated men. In reality, he had just triggered a tripwire connected to the entire American division. But this transmission alone was only the first step. A radio is merely a tool for moving sound. It cannot destroy a machine gun nest. The voice on the radio was often breathless, describing a fluid, chaotic situation from the bottom of a muddy ditch. The real mystery was not just that the message was sent, but how the American military apparatus processed it. To understand the terrifying speed of the counterattack, we must look at what happened at the other end of the signal. We need to see how. A whispered map coordinate was mathematically transformed into hundreds of pounds of falling steel in less than 3 minutes. They are completely isolated, walled in on both sides by impenetrable banks of dirt and roots 3 meters high. Miles behind the front line, safely tucked beneath a camouflage net in a French apple orchard, sat the receiving end of the invisible lifeline. This was the Fire Direction Center, or FDC. To understand the devastating speed of the American response, one must look inside this unassuming canvas tent, where the true lethality of the United States military was orchestrated. In most European armies of the time, artillery doctrine was surprisingly rigid. A battery of guns was often physically tethered to a specific forward observer or dedicated entirely to a pre-planned, inflexible schedule of bombardment. If a sudden, unexpected target appeared in the brush, redirecting heavy guns required a slow, bureaucratic process of routing requests up a rigid chain of command. The Americans had fundamentally redesigned this architecture. They centralized the mathematics of artillery, but heavily decentralized the authority to strike. Inside the FDC, there were no roaring guns or muddy trenches. There was only quiet, intense calculation. Men stood around a large folding table, staring at a topographical map covered in acetate and grease pencil marks. When the crackling voice of the pinned-down platoon leader came through the radio speaker, providing a rough map coordinate and calling for emergency suppression, the room moved with practiced, assembly line efficiency. A fire direction officer quickly verified the position. He did not need to ask a battalion commander for permission to fire. If the target was valid and the infantry was in danger,